This is the Deaf Blind Potter Show, and my name is Kelvin Crosby, and I am the Deaf Blind Potter. And if you're here to live beyond your challenges, you're at the right spot. So let's go on this journey and live beyond our challenges. Hey, it's so good to see you, even though I can't see you. It's another beautiful day in the neighborhood, and I'm so excited that you are here at the Deaf Blind Potter Show on KHNC 1360 on the AM dial. My name is Kelvin Crosby, also known as the Deaf Blind Potter, and today I'm not in the pottery studio. If you're watching the YouTube, I will make some pottery for you while we do today's show, and today's show is titled, Do I Live with Deaf Blindness? Or do I allow a DNA chip to give me my vision back? I said it. You're like, wait, you're talking about a DNA chip. Yep. A chip that would change the DNA to give me my vision back. Isn't that pretty cool? Right? But the question is this a good idea or is this a bad idea? And the only thing that we're going to be able to do, we're going to have to investigate this together. And I want to bring you awareness that this exists. And I think so many people are allowing the world to tell you, let's use technology to solve what God has created. That is wrong. Is God wrong? That's my question. Or are we just in a sinful world and that's why things are wrong? That's the $1 million question you got to answer yourself. So let's dive into this. So we're going to break this down into multiple different parts. First part of this segment here, we're going to dive into my deaf blindness and what it's all about. And then we're going to learn a little bit about this DNA chip and how does this thing work. And then we'll kind of work through the rest of this research and ask the question at the end, do I go get the chip or not? And I would love for you to interact with me on this. Send in your text messages and interact with me on this process, because if you think I should get the chip, I would love for you to make your case. If you think I shouldn't, then make your case as well, because I think this is something that needs to be talked about. And we need to be aware that this doesn't only affect my disease, my vision loss, but many other diseases and vaccines and protein cells and other things. Reinterpreting plants, that's what we're going to get into. So let's go on this journey, everybody, and let's do this. And let's dive into what is Usher syndrome type 2. Usher syndrome type 2 is a disease that affects my hearing and my vision. I was born hard of hearing, and I lost the clarity in my vision when I was 32 years old. I was legally blind when I was 19. But over time, my peripheral vision got worse and worse, and then the blurriness in my eyes just got really, really bad. And at this point in my life, I was like, I'm going to start looking for a cure. Earlier in 2018, 60 Minutes came out with this thing called CRISPR. Okay. C as in cat, R as in Robert, I as in igloo, S as in Sam, P as in Paul, and R as in Robert. Is how, if you want to look it up, how it's spelled. And when I started looking into this, I was like, okay, I think this could work. This would be cool. But then I just gave up on it and didn't worry about it no more. And even though there was somebody in San Diego doing the cure for my vision here at UCSD, and I'm like, okay, yeah. But I just kind of gave up. And then COVID hits, right, in 2020. And a bird in the air was saying CRISPR. So let's learn what CRISPR is all about.
In a document, if we suspect we've misspelled a word, we can use the find function to highlight the error and correct it or delete it. Within our DNA, that function is taken on by a system called CRISPR-Cas9. CRISPR is short for clustered, regularly interspaced short palindromic repeats. CRISPR consists of two components, the Cas9 protein that can cut DNA and a guide RNA that can recognize the sequence of DNA to be edited. To use CRISPR-Cas9, scientists first identify the sequence of the human genome that's causing a health problem. Then they create a specific guide RNA to recognize that particular stretch of A's, T's, G's, and C's in the DNA. The guide RNA is attached to the DNA cutting enzyme Cas9, and then this complex is introduced to the target cells. It locates the target letter sequence and cuts the DNA. At that point, scientists can then edit the existing genome by either modifying, deleting, or inserting new sequences. It effectively makes CRISPR-Cas9 a cut-and-paste tool for DNA editing. In the future, scientists hope to use CRISPR-Cas9 to develop critical advances in patient care, or even cure lifelong inherited diseases.
So I hope you kind of understood that. So CRISPR is a DNA paste and copy type of a system that you can just cut something out of your DNA and paste something else that works, and all good to go. Isn't that kind of cool? Nothing wrong, right? There's nothing wrong with this. Because we can work through this and solve my disease, Usher syndrome type 2. And when 60 Minutes presented this to the world, it was one of those, wow, yes, let's paste and copy and cut out the bad stuff and put in the good stuff. How CRISPR will it help me? And we still got to answer that question. Should I go get this or not? It's Calvin, the Deafblind Potter Show, and I tell you, I got quite the show for you. And this show, we're doing something completely different than what I normally do. I'm actually being a talk show host. What a concept. But we're diving into this thing called CRISPR and asking the question, should I get rid of my deaf blindness and embrace the CRISPR chip, the DNA reinterpreting chip that helps solve my disease, Usher syndrome type 2? And we're going to take this next couple minutes here to kind of understand all about it. And we're going to get some bunch of different little clips here through this segment here. And we're going to hear from several of the clips from 60 Minutes, and then also I'm going to kind of show something from the Mid magazine on what they identify CRISPR as. So the first thing I want to do is set up the scene and kind of give you the first major breakthrough with CRISPR. And I'm going to play this, and it's going to be interesting what you think, because at the end, there's a major punchline that really made me have some serious thoughts. Should I get CRISPR or should I not?
In 2011, scientists created glow-in-the-dark cats. The researchers took a gene from glowing jellyfish and inserted it into the unfertilized eggs of house cats. It was a neat trick, but they had a bigger goal in mind. They also made the cats more likely to be resistant to a feline form of AIDS by, again, manipulating their DNA. And cats aren't that different than humans. In fact, we share around 90% of our DNA with them. So why can't we engineer humans in the same way? Well, we can. Engineer ourselves to be resistant to life-threatening illnesses, that is. In fact, one scientist claims that he's genetically engineered 2 babies using a revolutionary tool called CRISPR. But what exactly is a CRISPR baby anyway? Would you like to be 6 feet tall? Or never bald? The secret to traits like these lies in the 6 billion letters of your genetic code. But there can be something else in there as well. Mutations. Genetic mutations are linked to at least 6,000 medical conditions, from sickle cell anemia to Huntington's disease. But what if you could make those mutations simply disappear? That's where the gene editing tool CRISPR comes in. CRISPR is made from specialized proteins and other compounds found in certain bacteria. Normally, these proteins protect the bacteria by destroying enemy invaders like viruses. But the inventors of CRISPR figured out how to turn those proteins against genetic mutations and other genes linked to disease. First, they give the proteins coordinates of the wanted gene. Then, CRISPR runs a seek and destroy function. After that, other molecules are dispatched to repair the gene with new, healthy DNA. And just like that, you can edit the human genome. But while the edits may be quick, their changes can last for centuries. Especially if you're editing the DNA in an embryo. Embryos start out with a single cell that eventually replicates into millions and then trillions more. So if you alter that initial cell first, you're manipulating the ingredients for every cell that follows later in life. And those same altered cells can be passed on from generation to generation. That's one reason why most experiments on human embryos haven't left the lab. That is, except for the work of Dr. He Jiankui. He claims to have used CRISPR to target and knock out the CCR5 gene in human embryos, which is linked to HIV infection. And then he did something that shocked the scientific community. He implanted the embryos into several women, one of whom gave birth to genetically modified twins. Resistance to HIV aside, most scientists say the procedure was too risky. At least 2 studies suggest that edited cells might actually trigger cancer. And another found that CRISPR can accidentally take aim at healthy DNA. So while CRISPR could make us immune to disease, who knows what else we might get on the side.
Okay, so, let's be straight. When you hear it from that perspective, this thing's starting to get a little creepy. Like, you can take CRISPR and make babies? And you can make a glow-in-the-dark cat? Yeah. I'm not sure how I feel about that. And truly, how do you feel about it? Because honestly, when I think about this, I'm like, I don't know, everybody. This sounds a little out of the ordinary. And So I started diving in a little bit more into this because obviously, like I said earlier, 60 Minutes did a whole segment on this and actually interviewed one of the people that invented this concept. And I tell you, I'm going to play 3 different videos here. And what's going to be interesting is the first one's going to get you your basis. The second one is going to get you a really interesting debate. And the third one is going to be pretty much asking the question, should we have even invented this technology? That's the question we got to figure out. So let's play this.
I think CRISPR, it's fair to say, is perhaps the most surprising discovery and maybe most consequential discovery in this century so far.
If you have never heard of something called CRISPR before now, that's likely to change. CRISPR is a tool for editing our DNA, reprogramming the genetic code, and it has scientists excited about tackling genetic diseases like Alzheimer's and cancer.
How many diseases are we talking about that this could be used to treat?
There are about 6,000 or more. The hope is that we'll be able to address most, if not all of them.
So when you hear it that way, it sounds really cool. Like, this is a good thing. This is a good solution for people like myself to get my vision back. I mean, how awesome would that be? It has a potential to do this. But let me play the next clip. And it's going to make you ask some questions. So let's play it.
I don't see the rush. Let's first try to get CRISPR working to cure diseases in people today, things where people really need that help. In my opinion, editing embryos, trying to change the next generation of humans is so fraught with issues. We better put up a big stop sign for now while we work through those issues, because it's not easy to take that stuff back. Imagine you do it and you get it wrong. How do you write a product recall notice? Dear Mom and Dad, sorry. This sounded like a really good idea to produce a baby that had this. But, it turns out it wasn't. Maybe Johnny shouldn't reproduce. Or maybe it turns out Johnny gets a genetic modification and Sally gets a genetic modification. But they're incompatible, and nobody thought to look for that first. And a whole new generation of genetic matchmakers have to arise to see what's compatible with what. There are so many ways something like that goes wrong once you cast things into the gene pool without thinking hard, that I think we can afford to proceed a little slowly while we figure out how CRISPR works in much more urgent situations right now. Real disease here and now.
I mean, this is hopeful. I mean, people are thinking in the right mind. This is the guy that was part of the invention of CRISPR. We shouldn't build new human. But if we look at the first video and said, there's already somebody doing that. I'm thinking, all right, well, who should I be listening to? How should I be adjusting that? Should I really get CRISPR in my eyes to get it back? Because he's saying that it's a good idea if we focus on the diseases, which is what Foundation Fighting Blindness is doing. If you want to support them, go to foundationfightingblindness.org and support them if you want to help cure vision loss. But this is interesting. And I got one more clip for you, and this one disturbed me a lot.
What did you think when you first heard about CRISPR?
For our purposes, we thought, wow, we could actually correct a gene in human embryos and prevent the transmission of genetic diseases to children and to their future children.
But that's the trigger for all the controversy. You're going to prevent the disease in an embryo.
Mm-hmm. As physicians, I think we're also trained to try and prevent disease. So if I know that you're at risk for a disease, doesn't have to be a genetic disease, and I know that there's a way that you can reduce your risk of that disease, potentially eliminate that, then I feel obligated as a physician to help you do that.
When I hear you talk, it almost sounds as though you feel you have a moral imperative to pursue this.
I do. I think if there is a way to prevent pain and suffering and transmission of serious diseases, then I think we're ethically obligated to pursue that research and technology.
Despite the controversy, despite the concerns, despite the criticism that you're playing God, you think it's imperative that you continue to pursue this?
Yes, I do, within the confines of the law, obviously. But I do feel that this is just an extension of all the other things we do in medicine. Treat disease and prevent disease.
I'm having some issues. There was one phrase in that last clip that I just played. It disturbs me so much. Are you trying to play God? Yes, I would like to play God, and I want to make, because I'm a physician, I feel obligated to play God. Are you God? No. You're a human being that is just as sinful as everybody else. Interesting. Yeah, so this is where I'm at now. See where my dilemma was? Remember when we started this show, we started, should I get my vision back by getting a chip to reinterpret the DNA of my vision so I can see again? Or continue to live beyond my challenges as a deaf-blind person? See, this is where I'm starting to scratch my head. Because do I want to have anything to do with being God? And having something that can interpret my DNA to give me my vision back? This is concerning to me. I would love to know your thoughts on this. So text me here at the KHNC number, and let's kind of have this conversation and see where we land. I'll see you on the other side. So, yeah, I'm still having questions, and you're listening to Deaf Blind Potter Show, and we're talking about, should I solve my vision issue with getting a DNA chip and to reverse the DNA damage that's done to my eyes? It seems like common sense, right? Let's get this solved and let's have me see again. And if you're new and you're just jumping on, basically we're talking about CRISPR, which is the DNA technology that you can rewrite the DNA code to take away and remove the DNA that is damaged. And in my case, of my vision, we would remove the retinitis pigmentosa part of my vision and then put in the normal part. But what we're learning is we don't know what the damage is. And this is where I'm starting to have some serious questions. Because what we've heard is that they're really trying to genetically create humans. They've already been able to make a glow-in-the-dark cat. And I'm like, okay. Well, there's a lady named Jennifer Danta, and she is the one behind kind of the whole movement of CRISPR. Obviously, the guy that we heard on 60 Minutes, I actually don't know his name, but Jennifer, there's this whole patent debate on who actually invented this and who's owns it. And Jennifer is one of those people in this conversation. And she has a Nobel Prize, yeah, whatever that's called. You know what I mean. And she's been awarded this for CRISPR. And she just did a TED Talk about 9 months ago. And it is kind of disturbing. And so what I'm going to do is I'm going to play part of this and then kind of give my commentary to it. And then we're going to ask the question, did they use CRISPR to make the liquid that went into people's bodies to try to prevent COVID? So, yeah, we're going to be kind of having this question because if I'm going to put this in my body to get my vision back, I need to make sure that everything that I'm doing is biblical and everything that I'm doing is okay. Because I don't want to be God by no means, like the lady said earlier. So let's take a look at the first clip I have for you on this TED Talk.
The essence of being human is that we solve problems. And when we're faced with enormous problems like disease and climate change, we need to solve them by collaboration. I'm excited to tell you about a new kind of collaboration that will absolutely create solutions to these big problems. It's a collaboration that's unexpected because it's between humans and the tiniest organisms that populate our planet, the bacteria and other microbes that live in, on, and around us. Bacteria may be small and unseen, but they often have inspired transformative innovations, including the one that has become the cornerstone of my own research. Over the past decade, I've been at the forefront of developing a revolutionary technology called CRISPR that has come from the study of how bacteria fight viral infection. CRISPR is amazing because it allows us to precisely edit the DNA in living organisms, including in people and plants. With CRISPR, we can change, remove, or replace the genes that govern the function of cells. This means that we now have the ability to use CRISPR like a word processor to find, cut, and paste text.
Hold on. Wait. Did we just hear that CRISPR is a cut and paste solution for plants and humans? Okay. Well, let's learn some more on this because I just want to point that out. Just keep your eyes open and your ears open here because the next thing you're about ready to hear got some red flags up.
CRISPR, amazingly, has already cured people of devastating disorders like sickle cell disease, and it's created rice plants that are resistant to both diseases and drought. Incredible, right?
I mean, that is really cool, right? It is solving a major problem. But my question is, what else are we doing with it? And do we know the long-term effects? If we change the DNA and the impact that might have on our food supply and ourselves as individuals. Do we know that, really? Or do we just know how to program DNA? Let's learn some more.
But the next world-changing advance with CRISPR will actually come from using it in a way that will allow us to go to the next level by editing genes beyond just in individual organisms. We now have the ability to use CRISPR to edit entire populations of tiny microbes called microbiomes that live in and on our bodies.
What? Warning, warning, warning. Let me play that again for you if you missed that.
We now have the ability to use CRISPR to edit entire populations of tiny microbes called microbiomes that live in and on our bodies.
We have the ability to take the organs of your skin and program that. Are you God? Because the last thing I remember, God is not in a human form. The one that was in human form, he died on the cross and rose again and took the cloud up into the heaven. And if I remember right, he made each and one of us in the womb. This is dangerous, everybody. This is extremely dangerous. And I'm having serious thoughts here. Let's just throw out the door the idea that I'm going to get my eyes back. Let's just ask the question, is this a good idea? That we should be even playing God? No. So God designed this earth the way he has. He has molded each and one of us as unique and special to him. You think about the pottery pieces I make, they're not perfect. None of us are perfect. I mean, I bet you if we go look at Jennifer and look at all inside of her, inside, outside, out, all around, she isn't perfect either. And I got some serious questions now. So when we come back, we're going to dive a little bit more into this TED Talk to see how really dangerous is this. Should I get CRISPR to change my vision from being deafblind to being seeing and hearing? That's the question we're answering today. And after the last segment, I'm fairly disturbed. You're listening to the Deaf Blind Potter Show, and my name is Kelvin Crosby. And I tell you, I'm a little disturbed at the moment. After what we've heard so far, and I'm not quite understanding all the details, but I felt like it was really important I did my research ahead of time. Knowing that what CRISPR is doing, which is the DNA chip that can reinterpret DNA, they now have the ability, without injecting anything on you, to program the microorganisms of your skin. Did you catch that part? Program the microorganisms of your skin. And the other part that just disturbed me like crazy was we can change whole populations. Who said that that's a good idea to change whole populations? Like, who said that? And why is Jennifer having this conversation, and why is she sharing it to the whole world? I'm just laying out the facts and what people are saying. I mean, we all know that they speak what they're going to do and hope that we all turn a blind eye. No pun intended. Did you get that? Woo. Oh man, I make my own self laugh. Oh man. Alright, anyways. So let's really think about this. Is this a good idea? Let's throw out the fact that I kind of already made my decision here that if we're already going to change our skin and our culture, our community based off of CRISPR DNA reinterpretation of your skin and your abilities to think and do and everything else, I mean, I'm having some serious thoughts. So what we're going to do is I'm going to kind of play a couple more clips here, and then I'm going to share my final thoughts at the end of the show here. So let's play this next clip.
For decades, scientists studied bacteria one organism at a time as if each type of bacteria behaved independently. But we now know that bacterial behaviors, both good and bad, result from their interactions within complex microbiomes. In humans, dysfunctional gut microbiomes are associated with diseases as diverse as Alzheimer's and asthma. And in farm animals, microbiomes produce methane, a powerful contributor to climate change.
Climate change, and farting. Man, I sure love a good fart. I'm just telling you. Why do we want to take that away? Don't you love making the room smell up and get stinky? I mean, yeah. I mean, yeah, continue listening.
But when they're healthy, both human and animal microbiomes can actually prevent disease and reduce methane emissions. So to harness these benefits, we need a way to precisely and reproducibly control these microbial communities.
This is starting to sound a little bit like the World Health Organization, the WHO, wanting to control us and the animals and the plants, but this is the technology that does it.
You might be wondering how we can take this new knowledge and harness it to solve real-world problems. Well, we're bringing together these two breakthrough technologies, metagenomics and CRISPR, to create a brand new field of science called precision microbiome editing. This will allow us to discover links between dysfunctional microbiomes and disease or greenhouse gas emissions. We can develop modified and improved microbiome editors and show that they're safe and effective. And then we can then begin to deploy these optimized solutions to create the kinds of solutions that will be transformative in the future.
Well. Climate change has reached its finest. And I tell you, this is where now with their new technology they talk about, which I have not done my research on, but what I'm coming down to is when we started this show, we were starting the show with, should I get my vision back or not? And then I decided to go do some research. And if the research contradicts what the Bible says, then yeah, we got problems. And here's what's really interesting is, let's just be straight. Climate change is a hoax and a religion. It is a religion of the devil. It is something that you worship. And people that believe in climate change are worshiping the devil. Let's just be straight. That's all I'm going to say on that. I'm not going to get into conspiracies that people are like, we're not going there. I'm just laying out the facts for you. I'm just laying out what this lady, Jennifer, who had the Nobel Peace Prize on CRISPR, and her colleagues now have even a bigger weapon to change our DNA to force us to do things that we don't want to do, and help with climate change, and have us all bow down to climate change. What is concerning to me is, when do we start being God? God is the creator, the maker, and he is the inventor of the DNA. And it's one thing to cure diseases, to help people like see again. It's another thing. But when you start talking about changing whole communities and cultures and having us all be controlled by you, that sounds more like you're trying to be God in a whole different way. So stay tuned. I'll kind of tell you my final thoughts and we wrap up this show. It's Galvin, the Deafblind Potter, here at the Deafblind Potter Show on KHNC 1360 on the AM dial, and we're wrapping up our show. And I'm going to play this one clip, and then I'll kind of give my final thoughts.
So, how does this affect our health and the health of our planet? We know the poorest countries and people are the most affected by climate change, and it's a problem created by the wealthiest people. And methane is a big part of the problem. It's been a major contributor to rising global temperatures since pre-industrial times. Specific microbiome compositions in livestock can actually reduce methane emissions by up to 80%. But doing that today currently requires daily interventions at enormous expense, and it just doesn't scale.
Okay, so if you want to hear the rest of that, I'm going to have it in my description on the YouTube and also on the deafblindpottershow.com website. All the resources I've used for today's show will be there. And just the more I listen to this and the more I've kind of been studying this, I don't think it's a good idea. I don't think it's a good idea for me to get my vision back using CRISPR and using this technology. Because I'm just feeding the beast if I do that. And the other thing is, I have more joy in my life being deaf-blind than if I could see. Yeah, it sucks. Yeah. But life sucks. Let's just be straight. Life sucks. Yeah. We don't live for happiness when we have Christ in our souls. We live for joy. We live for rejoicing in our suffering, persevering, and building a character that has hope in Christ. So, life itself on earth sucks. Yes. I'm just being straight. But when you have joy in Christ, life on earth becomes so joyful and so exciting. It's not based on happiness. It's not based on, oh, the world wants to be more climate change and we want to bow to the climate god. No. When you have Jesus in your heart, in your salvation, and he lives in you, you find a joy that is so beyond this earth, beyond climate change, beyond farting, you know. We are children of God. He is the creator. He is the maker. He is the one that molded us in our mom's womb and give us life. Why we have diseases and issues on earth is because of sin and Satan himself. That's all I gotta say on this. I could drop the mic and walk away right here. And I'm just telling you, do your research before you go have a surgery or have something change in your life. Because is it really what God wants you to do? So like I always say, to wrap up any of my shows, go live beyond your challenges, and I will see you next week. That wraps up the Deaf Blind Potter Show. Thanks for joining me, and share this video and encourage somebody to live beyond their challenges so that way we all can persevere through the struggles of life and overcome the challenges and have hope to live beyond our challenges. I'll see you next time.